There are storms that come and go, storms that rattle windows, knock out power for a few hours, and leave behind nothing more than wet roads and fallen branches. And then there are storms that are different from the moment they appear on a weather map. Storms that carry a particular signature in the atmospheric data, a combination of ingredients and timing and positioning that makes every experienced meteorologist lean closer to their screen and start making phone calls. This is one of those storms. This storm is about to cause serious problems. Not inconveniences, not the kind of disruption that resolves itself by morning. Serious, potentially catastrophic, multidimensional problems that will affect transportation networks, power grids, river systems, agricultural land, emergency services, and human lives across a wide geographic area. Before this storm makes its full impact felt, you need to understand exactly what it is carrying, exactly what it is going to do, and exactly why the people whose job it is to watch the atmosphere are treating this one with a level of urgency that the public has not yet fully matched. Let us begin with what makes a storm cross the line from severe to seriously problematic, because that distinction matters enormously. Every day somewhere in the world, a thunderstorm produces damaging winds, or a coastal low brings heavy rain, or a winter system drops significant snow. These are routine severe weather events, and the systems built to handle them, emergency management infrastructure, utility repair crews, road clearing equipment, flood control infrastructure, generally cope with them within a predictable recovery window. A seriously problematic storm is different in kind, not just degree. It is a storm whose impacts exceed the design capacity of the systems built to manage them. It is a storm that arrives at the wrong time, in the wrong place, with the wrong combination of hazards stacked on top of each other. It is a storm where one hazard creates the conditions that make a second hazard dramatically worse, and the second hazard amplifies the third, and by the time the full impact is being assessed, the response systems are overwhelmed not because they failed, but because the storm was operating at a level above what any reasonable planning process anticipated. That is precisely the category of storm now forming and tracking toward populated areas. The first and most immediately dangerous characteristic of this storm is its wind field. Not just the peak wind speeds at the center or in the strongest convective cells, but the spatial extent of damaging winds across a wide area simultaneously. There is a critical difference between a storm that produces extreme winds in a small area and a storm that produces broadly damaging winds across hundreds of square miles at the same time. The latter is far more operationally destructive because it overwhelms repair capacity. When a tornado touches down and destroys a neighborhood, the rest of the surrounding region remains functional and can support the response. Utility crews from neighboring areas can be brought in. Roads into the damaged zone remain passable. But when a storm produces winds of 60, 70, and 80 miles per hour simultaneously across an entire metropolitan region or a multi-county rural area, the damage is everywhere at once. Every road may have downed trees. Every utility corridor may have damaged lines. The crews needed to restore power cannot get to where they are needed because the roads are blocked by the same trees that are blocking the power lines. This is the scenario that the current storm is setting up across its projected impact corridor, and it is one of the primary reasons emergency managers are already activating response protocols days before the storm arrives. The wind speeds now being projected for this storm are not extreme by tropical cyclone standards, but they are being generated by an extratropical system with a much larger wind field than a typical hurricane of equivalent peak intensity. A Category 1 hurricane with 80 mile per hour winds carries those peak winds in a relatively compact zone around its center. An intense extratropical cyclone with 70 mile per hour winds can sustain those speeds across a wind field 500 miles wide. The total kinetic energy being delivered to the landscape by the extratropical system is often far greater than the kinetic energy delivered by a stronger but more compact tropical system. Trees that have been standing for a century are toppled not because the wind is the fastest they have ever experienced, but because the wind blows hard, continuously, from the same direction, for 6, 8, or 10 hours without let-up, progressively fatiguing root systems and structural connections until failure occurs. Extended duration, high wind events are categorically more destructive to the built environment than brief extreme wind events of higher peak intensity, and this storm is tracking to deliver exactly that kind of extended high wind event across its full impact zone. The rainfall component of this storm deserves equal urgency, and perhaps even more attention given the state of the ground across the projected impact region. Soils across significant portions of the storm's path are already carrying above normal moisture content from earlier precipitation events this season. Stream flows in multiple river basins within the projected impact zone are running at above average levels for this time of year. This means that the rainfall this storm delivers will have dramatically reduced infiltration capacity to absorb into, and a dramatically higher proportion of every inch of rain that falls will become direct runoff into already stressed river and stream systems. Rainfall totals being projected for the heaviest precipitation zones range from 4 to 8 inches over a 24 to 36-hour period, with localized amounts potentially exceeding 10 inches where the storm's heaviest training rain bands set up. On normal soil conditions, those totals would be serious. On already saturated soils, they are a recipe for flooding that will exceed what the historical record considers normal for the affected river systems. Flash flooding is the most immediately life-threatening aspect of the rainfall this storm will produce, and the statistics around flash flood fatalities are genuinely shocking in how consistently they are ignored by the public. Flash flooding is the #1 weather-related killer in the United States, surpassing tornadoes, hurricanes, lightning, and heat in an average year. Approximately 88 people die in flood-related incidents in America each year, and more than half of those deaths occur in vehicles. The reason vehicle-related flood fatalities are so persistently high, despite decades of public awareness campaigns, is that moving water is extraordinarily deceptive in appearance. A road covered by 6 inches of fast-moving water looks passable to a driver who does not understand fluid dynamics. It looks like a shallow inconvenience rather than a potentially lethal hazard. But 6 inches of moving water exerts significant lateral force on a vehicle. A foot of moving water can cause loss of vehicle control. 2 feet of moving water will float and carry away most passenger vehicles regardless of their size or weight. The physics does not negotiate. The water does not care about the urgency of your destination or the capability of your vehicle. And this storm is going to produce the exact conditions under which these fatalities repeatedly occur, rapidly rising water on roadways that appear passable until they are not, in multiple locations, across its impact zone simultaneously. Beyond the flash flooding threat, this storm is also positioned to produce significant river flooding with a much longer timeline and in some ways a more insidious impact. Major rivers do not respond to rainfall instantly. Water that falls in the upper watershed must make its way through tributaries and smaller streams before it accumulates in the main channel and begins to raise the gauge at populated downstream locations. This delay, which can range from hours to days depending on the watershed size and slope, means that river flooding from this storm will continue to develop, and in many locations will not crest until well after the storm itself has passed and skies have cleared. Communities downstream of the heaviest rainfall zones may experience their worst flooding 2 or 3 days after the storm, under clear skies and conditions that psychologically feel like the crisis has passed. This is when people let their guard down, when they return to flood-damaged areas too soon, when they attempt to drive roads that appear dry but cross over bridges with surging rivers running far above normal beneath them. The river flooding chapter of this storm's impact story will be written over 5 to 7 days minimum, long after the wind and rain have moved on. The power outage dimension of this storm has consequences that extend far beyond the inconvenience of being without electricity for a few hours. Extended power outages, meaning outages lasting more than 24 hours and potentially stretching to 72 hours or longer in the worst affected areas, carry serious public health implications that are often not communicated clearly enough in pre-storm messaging. People who depend on electrically powered medical equipment, including home oxygen concentrators, ventilators, infusion pumps, and refrigerated medications, such as insulin, face life-threatening situations when power is lost for extended periods. The number of Americans who depend on home medical equipment has grown substantially over the past 2 decades, as medical technology has advanced and more care has shifted from clinical to home settings. A storm that produces widespread extended power outages across a densely populated corridor is simultaneously creating a medical emergency for thousands of individuals whose specific vulnerability is invisible in the aggregate statistics of storm damage. Carbon monoxide poisoning from improperly used generators is another consistently documented cause of storm-related fatalities that is almost entirely preventable. In every major power outage event, people bring generators indoors or into attached garages and are killed by the colorless, odorless exhaust. This happens in every single major outage event, despite decades of warnings, because the urgency of keeping lights on or food cold overrides the abstract knowledge of the danger. The transportation network disruption this storm will cause has cascading economic consequences that begin before the storm arrives and extend weeks beyond it. In the immediate pre-storm window, supply chains that depend on just-in-time delivery are already being stressed as carriers and shippers assess routing options and make contingency plans. Airlines are already reviewing schedules for hubs within the storm's projected impact zone, and the cancellations that begin 24 to 36 hours before a major storm hits can strand tens of thousands of travelers and disrupt logistics chains that have ripple effects across industries. Road closures from flooding, downed trees, and damaged infrastructure during and after the storm will isolate communities, delay emergency response, and prevent the movement of repair crews and equipment to where they are needed most. Rail networks that carry freight through the storm corridor will face service interruptions from both wind damage to infrastructure and flooding of tracks and access roads. The economic cost of a single major storm event through transportation disruption alone routinely runs into hundreds of millions of dollars even before a single structure is damaged or a single power pole is downed. The agricultural impact of this storm is another dimension that deserves direct attention, especially given the timing within the growing season. Wind damage to standing crops can be catastrophic and largely unrecoverable. Corn that is blown down, a phenomenon called lodging, loses a significant fraction of its yield even if the plant survives, because the plant's ability to photosynthesize and direct energy to the developing ear is compromised by the structural damage. Fruit and vegetable crops can be stripped from plants by high winds in a matter of minutes, eliminating an entire season's production for growers who have already invested months of labor and input costs. Flooding of agricultural fields during critical growth periods can cause root damage, soil compaction from heavy equipment operating in saturated conditions, and loss of applied fertilizers and soil nutrients through erosion and leaching. For farmers operating on narrow margins in a sector where a single bad season can be financially devastating, the storm now approaching is not an abstract weather event. It is an existential economic threat. One of the most serious and least publicly discussed risks associated with a storm of this magnitude and character is the threat it poses to critical infrastructure beyond the power grid. Water treatment and wastewater management systems depend on continuous electrical power to operate pumps, maintain treatment processes, and manage sewage flows. When power is lost and backup generator capacity is exceeded or fails, drinking water systems can lose pressure, creating conditions under which contaminants can enter the distribution network. Wastewater systems can overflow, releasing untreated sewage into streets, yards, and waterways. The public health consequences of drinking water contamination and sewage overflow events following major storms are well documented in the epidemiological literature and include outbreaks of gastrointestinal illness that peak in the weeks following the storm event. These are not hypothetical risks. They are documented outcomes of previous major storm events affecting urban areas, and they disproportionately affect communities with older infrastructure and fewer resources for rapid emergency repairs. Communications infrastructure is another system that fails in ways the public rarely anticipates until it happens. Cell towers have battery backup systems designed to maintain service during power outages, but those battery systems are typically designed for 4 to 8 hours of operation, not for multi-day extended outages. When the battery backup is exhausted and generator fuel runs out or generators fail, cell towers go dark. In a major storm scenario where large numbers of people are simultaneously attempting to use their phones to call for help, check on family members, and access emergency information, cell networks become congested and unreliable even before backup power issues arise. The lesson from every major storm event of the past 2 decades is identical. Do not assume that your cell phone will work when you most need it during or after a major storm. Have a battery-powered or hand-crank weather radio. Know the location of your nearest emergency shelter. Have a predetermined family communication plan that does not depend on real-time cellular connectivity. The storm now approaching is not a storm that will announce itself dramatically in its opening hours and then relent. The atmospheric setup supporting it is robust and will sustain its intensity throughout its transit of the impact zone. It will arrive with wind, and the wind will not diminish quickly. It will deliver rain, and the rain will not stop until the soil is beyond saturated and the rivers are running above their banks. It will produce flooding that develops during the storm and continues to worsen after the storm has passed. It will take down trees and power lines across a wide area simultaneously, and the restoration of services will take days, not hours, in the most affected locations. It will create hazardous conditions on roads that will persist for days after the storm itself has moved on. It will stress every system, natural and human, that stands in its path. This storm is about to cause serious problems. The data is unambiguous. The atmospheric dynamics are clear. The historical analogs are documented. What is not yet determined is how seriously the people in its path take the warnings they are receiving right now, in this window before the wind begins and the rain starts and the water rises and the options narrow. Preparation is not panic. Checking your home's flood risk is not overreaction. Ensuring you have food, water, medication, and a battery backup for at least 72 hours is not excessive caution for a storm of this caliber. It is the minimum rational response to what the atmosphere is preparing to deliver. Know your evacuation route before you need it. Know where you will shelter if your home is compromised. Know the difference between a flooded road that looks passable and a flooded road that will kill you. And understand that from inside a vehicle at night in heavy rain, you cannot reliably tell those two things apart. The time to make these decisions is right now. Because this storm is coming and it is bringing serious problems with it, and the only question that remains is whether you will be ready when it arrives.